All right, well, let's get started. Good afternoon, everybody. The keynote stunned you into silence. Good afternoon, everybody. There we go, a little bit better. Welcome to Avoiding Hashtag Cloud Fail, Learning Lessons from Windows Azure. My name is Mark Russinovich. Some of you probably saw me in the keynote this morning. I'm a technical fellow in Windows Azure. I've been in that's going to take a while to fix. Microsoft Azure for the last 4 years. And I've been working on primarily the compute stack, but really our compute strategy going all the way from resource groups, which I was the architect for, all the way down to how we create our data centers and what kind of servers we provision and our strategy for disaggregated storage. And so I get to have a lot of fun all across the stack. Now, this session today, I think of it as a case of the unexplained for the cloud. How many people have been to my case of the unexplained sessions before? So quite a few of you. So in this session, I'm going to be crashing 10,000 virtual machines and then debugging them with Process Explorer. So no, I'm just I'm not doing that. What I'm going to be doing in this session is talking about some of the lessons, the rules that we've come up with as we've developed Azure, as we've made mistakes and been reminded of these painful lessons, these rules that we need to follow as we develop and operate our cloud software. As I go through this talk, some of the rules you might say, well, duh, that's obvious. And some of them are obvious, and some of them are ones that we just know. But for some reason, you kind of don't really think of explicitly. And the cloud is very unforgiving. It'll remind you of every little tiny mistake you make. And when it reminds you, sometimes it can remind you in a very big, painful, and public way. And so if we make these mistakes, then I think it's fair to say that some of you might make these mistakes. And so what I hope that you get out of this session is by looking at the mistakes we've made, that you can avoid making the same mistakes, and we can all have a better cloud experience together. This talk is not to... Let me see if I can get the clicker to work. It was working a second ago. Yeah, cloud fail right away here with the clicker. No, the clicker is not going to... Maybe I have a second clicker. No, my backup click. See, rule of the cloud, have a backup. And that's not going to work. So maybe I'm going with the manual. All right, so there's a few basic rules that everybody should know when you're developing the cloud. And they include things like automation. You've got to automate to run in the cloud. Automation from deployment, automation to testing, automation to update. You need to scale out. Cloud is a different world. It's not a scale-up architecture like we saw in the PC server era or the mainframe era. It is one where if you want to get to scale, you need to go out, not up. It's one where you test in production. It means that this isn't a box product world where you go test in labs and then eventually give it to a customer and let them operate it. It's where you actually push it out, and the only way to push out and update quickly is to have your tests go actually live and see what customers experience. It is to deploy early and deploy often. Part of being able to test quickly and innovate rapidly is to be able to push out updates, make mistakes, and then fix those mistakes very quickly. These are all just the tried and true lessons, and I'm not going to be covering these really in this session. And by the way, there's another one, which is always blame the compiler if you're a developer for any mistake. That's just a golden rule of any software development. But there's lots more rules that we've learned, and that's what I'm going to take you through today. I'm going to take you through real world. Every one of these is a real Azure incident, sourced in a real Azure incident. Some of these are public incidents. Some of them are internal incidents. Some are incidents that we've had in our test environments. They're all real. And in some cases, I'll be showing you text from the developers. In some cases, I'll be showing you text from internal root cause analysis. This is all just brutally honest and open. Before I get started, I do want to introduce you to a little bit of Azure architecture that will help set context for some of the incidents that I cover. This is just basic architecture. At the heart of our orchestration system is a component called RDFE. Anybody know what RDFE stands for? Red Dog Front End. Red Dog Front End, it's our front end service. It's basically our control plane and provisioning system in Azure. Anybody know where the word Red Dog comes from? Yeah, some people know. Where? You've driven past the Pink Poodle. It's named after a place that I think is not too far from here. I've never been there. San Jose, it's in San Jose. I've never been there. But I've been told, do not do web searches for it at work. Now, so what's that? Very fine. And I think that's Dave Cutler, the original architect for Windows NT, named the Azure project, before it was a product, Red Dog. And he named it that because he liked the pink poodle sign, I guess. I guess it was the sign that he liked. And so, in any case, that's RDFE. And we still use the term RDFE and Red Dog internally in a lot of places because it's hard for that kind of stuff to get completely scrubbed out of the system. Now, there's two ways into Azure, or multiple ways into Azure. It's a REST API on the front, so you can talk to it through the portal. I had dinner with Jeffrey Snover last night. He forced me to put that up there and say another way, and he claims it's the best way to talk to Azure is through the PowerShell. Then RDFE talks to what we call resource providers behind it. These include things like Azure Database and Service Bus and Access Control Service or Windows Azure Active Directory and storage, and then compute. Compute is where we provision VMs. And what provisions VMs is a component called the Fabric Controller. The Fabric Controller, we have different stamps or clusters of Fabric Controllers that manage groups of about 1,000 servers. So that's why you see a bunch of Fabric Controller instances there, and that will become relevant a little bit later. The agenda, I've divided it into two sections. Minor fail and major fail. By the way, hashtag, do not tweet about this and say hashtag cloud fail. I don't want, put hashtag cloud awesome if you're going to tweet about this so that people don't get the wrong impression. But I've divided this into two sections, minor failures, which are more point incidents of little specific learnings, and then major fail, which are more public or customer impacting incidents that might have several learnings in them, but were bigger scope for us. Let's start with minor fail. And this one, customer started to report that the portal was not showing some of their resources that they've provisioned, like mobile services or media resources. So we dug into this, and here's the actual incident notifications, event notification. You can see there, we generate these for every time there's some incident that we've discovered in our live site operations. I don't know if you might not be able to read that, but it's a severity level 2. We categorize incidents by severity level. Severity level 3 means not urgent, not pressing, not having an impact on customers, may have an impact at some future date. It's something we need to go address, but it's nothing urgent. Severity level 2 means it's impacted some of our services in a localized way. It's not, it's a problem that we need to urgently address, but it's not like a catastrophe. Severity level 1 means that that it's more of a global outage. It's affected multiple services or geo-scale kind of outage. And severity level 0 means the place is on fire. People potentially could lose data. We've only had one severity 0 incident in the history of Azure. And that's like the nightmare one, because customer data loss is way worse than just customer data inaccessibility. In any case, you can see this one's severity level 2. Now we researched this one. The root cause was that RDFE had pushed a change, an update, that changed or the case sensitivity check on the resource provider name. And so lowercase mobile service no longer matched mixed case mobile service, and that caused RDFE to say these things don't exist because they don't match a known resource provider. Here's another example of an incident. This one, when RDFE, we provision it, it has to know which fabric stamps exist in the world. And so we've got a database of fabric stamps that we populate for RDFE so it knows where it can go to deploy virtual machines. So the build-out team says, hey, wait a minute, AM2 prod app 03, this is the internal code names for fabric stamps. AM2 means Amsterdam, data center 2, prod means production as opposed to stage or test. App 03 means it's a compute cluster instead of a storage cluster, and it's the third one. And that thing wasn't showing up in RDFE inventory. They do a root cause. Turned out that the build-out team had entered mixed case label for that fabric cluster name instead of all lowercase. And RDFE does lowercase checking for fabric stamps against its inventory. So again, on a mismatch of case, failed to show the cluster. And so this is the build-out team's request that somebody go fix the casing in the database. So the bottom line is here, you need to be sensitive about case. Case has to be handled kind of on a case-by-case basis. And I had an incident last week where I used the wrong case talking to my wife. And that resulted in a Sub-Zero incident at home. And she wants me to go to case sensitivity training now. All right, so there's different types of strings that you need to worry about for casing. There's case-insensitive strings, and so these are the strings that we've categorized as these are insensitive, and so you need to perform case-insensitive matching against them. And then there are a bunch of strings that are case-sensitive. And these include, this is kind of just a compilation inventory. A lot of us just inherently kind of know this stuff because we're dealing with these kinds of strings all the time. But what we've done is write this down and make sure that developers know it so that they treat them appropriately. And we've also come up with general rules about how to deal with case, because there's new situations that arise where you got to consider how should we treat the casing on this thing. So one, of course, is to comply with whatever the industry says about the casing. Another one is that if there's an external system that is case sensitive or case insensitive, we need to do the same thing as they do. That user-friendly text should be case sensitive. That all other text besides that, if we're creating new strings, should be case insensitive. That we've got to preserve the strings. When you're getting a function in your past text, do not change the casing as you pass it along to other functions, because who knows what's going to happen to that. And then finally, be helpful, and at the entry points of strings into the system, document what you expect the casing to be so that a developer that's going and looking at it can follow that casing through from where it came in and not have to guess. So that's one example of the type of thing that I'm going to be talking about this afternoon. Logging, that's another case, another situation where logging, we run into the same issues again and again with logging. And a little more detail on your log or your log messages or error messages can add so much. You know, back in the days of box products, when somebody else is operating the thing, like a system administrator, and you're handing the box product off to them, it's okay to put unexpected error, because it's like, whatever, I'm not dealing with it, so good luck with that. But not when you're operating it yourself. It's a totally different mindset. I think you probably encountered this. It's like, oh, if I've got to go debug, figure out what unexpected error is, well, that's a different story. I better not have unexpected errors in my software. So we've run into this ourselves. Here are real examples that we've run into. Error messages that our own testers or developers have seen that have caused them problems. In this case, you can see that there is an exception being thrown, and it says that some service name doesn't exist, but it doesn't say the name of the service. And so when you're going to figure out, okay, what happened here? What service is it complaining about that it doesn't know about? If you don't know the name, you can't go back and look at other logs for correlating information to find out where this thing got lost track of. Here's another example. In a test environment where not all the features were enabled, tester ran into this. VM create error. The subscription is not authorized for this feature. Okay. Which feature? And so then they had to go figure out, okay, what beta features are enabled in this thing for these test accounts and which ones are in production, and then let's go, it just adds a lot of time to the diagnosis. In this one, intermittent failures, because this would throw error message would get popped out sometimes. Status code 400, service management error code, missing or incorrect version header. The versioning header is not specified or was specified incorrectly. Well, first, which one was it? Was it not there, or was it incorrect? And if it's incorrect, which one was it, so we can figure out where the bug is that's passing this incorrect version. You can see all of these caused hours and hours of time for developers and testers to go figure out the root cause. So basically log as if it was if nobody was looking. It's this kind of thing that we got. Just log verbosely, because you never know when that little extra piece of information you put in there can shave hours off of a debugging session. Now, code matters. Code hygiene matters even in the cloud. Actually, that's that ever is a animation. Sorry about that. But this is an example of many cases we've run across that were putting a hard foot down on to try to squash these things. Anybody spot the coding error in this? That's right. That comma there is premature. That parenthesis should not be before that comma. And what this did is it broke log filtering. This is an audit log filtering code, and so that statement returns true. That means log everything. And so this thing rolls out, and then the audit logs just start exploding, flooding the system. And that throws off alerts, and then we go back and figure out that this is the problem. So the rule, build with warn as error. How many people do that? How many people do not do that? So you need to do that. And by the way, when you do that, do not suppress compiler warnings. And that's where the ever comes from. Never, ever do that, because you've defeated the whole purpose. I mean, you can get back to whatever error level you want if you suppress enough. All right, so let's talk about exceptions now. How many people like exception handling? How many people hate it? It's like a horrible thing. Yeah, exception handling is painful, isn't it? Especially when you're calling into code that you didn't write, and you're like, I don't know what the hell kind of exceptions this thing is going to throw at me. So how do I deal with that? Well, should you have a catch-all? Or should you fail fast? Should you just swallow the things that you don't know? Or should you just always say, if I don't understand it, boom, crash? Well, the storage team in Azure, back in the early days of Azure, they said, if we don't understand it, we need to fail fast. That's the safe thing to do. And you know what that caused? Is somebody would have a parsing error on the REST code coming in from clients that would throw a null pointer exception or integer overflow exception, and boom, the storage front end would crash. Well, you know the thing about the cloud is that when a client gets back an error or nothing, what do? They retry. So then they get redirected to a healthy front end. And then what happens? That one crashes. And then eventually all of the front ends have crashed because of an integer overflow that could have been swallowed innocuously. It turned into a massive DOS. So, by the way, so what do you do with this? It's a conundrum. Visual Studio says never catch all. It has this, FX cop rule, never catch all. If you see one of these catch alls, it says barf, bad. But like I said, if you catch unrecoverable errors, then you can leave the component in a completely worthless state. On the other hand, like I said, with that example, you catch everything, and you could be opening up yourself. You fail fast on everything you don't understand, you could be opening yourself up to DOS. So what do? Remember I said don't suppress any of the compiler warnings? We'll suppress that one. There's an exception to exceptions, and that's the exception. Suppress that one, and follow this rule. Crash if it's not user-initiated and it's unrecoverable. So out of memory, can you recover from that? No, just crash. Otherwise, log an error and return an error to the user. And this is the actual code from the storage front end, which does this logic. You can see that there's a check up here. Now that thing is a massive case statement against a whole bunch of exception types that are known to be unrecoverable. And if it matches any of those, then it'll fail fast. If you fall into the else, it calls into this function. What this function does is logs once per hour per type of exception and returns status 500 to the user. Internal server error. And it logs only once per hour so that you don't allow users to DOS your error logging with something that you should go fix. And so that is the rule on exception handling. Some further rules learned by us about exception handling in cloud services. Exceptions are very expensive in Azure. No, I mean really expensive. If somebody throws an exception, they've got to buy me a margarita. No, not true. But exceptions are expensive because, well, I'll talk about why they're expensive. But you should never throw exceptions for expected errors. You should always return an error code and let things deal with that error the natural way. So for example, if somebody's looking for a resource and it's not found, do not throw an exception not found. Return not found and handle it that way for performance. And then if you're going to log the exception, be careful about logging a stack trace for it, because stack trace logging is very CPU intensive. And again, in a box product world where you have one single customer maybe doing this once in a while, that's not a problem. But when you're in a cloud scale and you can't control or predict what your clients are going to do, something like this could be a DOS on your service too, if you're doing this a lot. So the rule is to control the logging of your stack just once per request, and try to do it only when you've turned on a debug mode, because you need to catch more information. Also, rethrowing from async end, kind of worthless, because you've lost the original stack trace. Now what people do is they'll go and do a remote stack trace. That's really incredibly expensive, because you're holding up the source thread while you're doing that. So what we do is try to recreate an exception on the main thread with the actual exception as an inner exception, and log that one. And again, apply the same rules we've talked about. This next example is a little bit higher level. Like I said, RDFE serves as the front end to a whole bunch of services. And testing of the front end in test environments requires interaction with the resource providers. Now, when we're in testing, we've got lots of different versions of RDFE in testing. There's not just like one test version of RDFE. There's different feature teams doing the testing of their own stuff. We've got different versions at different levels. We've got production versions of different levels. And so this is what we would have to do if we wanted to really test one RP uniquely against each RDFE, is to deploy lots of RPs for each RDFE. And that is just not practical. Just not practical to go and set up the configurations for all those resource providers, dozens now, for every single test instance of RDFE. So the test team, the test automation team, came up with a workaround, which was to have one primary test RDFE, have one test resource provider for each resource type, like SQL Azure, and then have test RDFEs that they could run test cases on that would all share the same RP. And now the RP needs to call back into RDFE a lot of times. The RP, single RP, has to know about the golden RDFE, so it talks back to that primary. And you can see the problems with this are that because they're all sharing the same state, these tests are starting, they can interfere with each other. So this is the downside of this approach. So what we've decided to do is to make these components follow a registration callback model, so that RPs aren't just married to one RDFE, they can talk to multiple RDFEs. And they register, so when RDFE talks to it, it says, hey, I'm this RDFE. When I talk to you, you want to talk back to me? Call me back at this endpoint. The nice aspect of this is that this is the way that you deal with layering cycles, is you break the layering cycles using an extension model pattern, where you have a base layer that knows nothing about the layer above it, and the layer above it registers itself with the layer below. So if the layer below needs to talk to the layer above, it can call back through that extension handler. And that way you have this nice separation of concerns for startup ordering. You start up your base layers first, and then your extension layers on top of that. And you get rid of cycles, which are really horrible things when it comes to understanding dependencies, is these cycles. So this has lots of benefits. And now with this model, RDFE test 1 talks to SQL, that SQL Azure or Windows Azure Database endpoint, gets called back for its API requests, and so on. And now they're completely isolated from each other. And that's the way that we have now scalable testing of RDFE with not having to create lots and lots of resource providers. Speaking of testing, these are some incidents filed by our DevOps test people, which are complaints against a different developer that it's like, what the hell? So these are the actual bug numbers. I've decided just to include them for authenticity. With the titles, Testability, Expose Delete Extensions API. So I talked about these extensions this morning in the keynote. Those things, when the developers created them, had a register extension API for a subscription, but had no delete subscription API. So whenever tests wanted to make sure that extensions could be added successfully, they had to start with a clean subscription. And creating subscriptions is a very expensive operation. Ideally, they just want to say, delete extension, delete extension, add extension. Instead, they got to do add, delete subscription, add, you know, because they can't delete the extensions. And this other one's very similar, unentitled resource for subscription. So resource providers are entitled on a subscription by subscription basis. The same problem there. Couldn't delete them, causing test flows to really slow down because you had to go and reprovision subscriptions and delete them. So the rule is to always have CRUD for every one of your resource types. Never skimp and say, you know what, deleting this thing isn't something that would really happen in production, so I can skip it, because then you're going to be hurting your tests. This one I call back to the future. This is about forward compatibility rather. So this is code from RDFE that tested against a Fabric, where the Fabric controller would talk to it, and if RDFE asked it, hey, what are your capabilities? And the Fabric told it something it didn't understand, it would say, all right, then I don't understand what the hell you're talking about. I'm not talking to you anymore. And so the problem this caused is that when the upgrade order changed, if the Fabric got updated first before RDFE got updated to know about the capability, then you had the Fabric and the RDFE not talking to each other. If you did the other way around, then things would work. And obviously, having a dependency order on update is very painful. We've made this mistake a number of times. Make sure that you've got forward compatibility where it makes sense, and that will make your updating a lot more seamless. N-1, N+1 where possible. Of course, that's not always possible, but you should try for it. If a parameter can be ignored innocuously, ignore it. If it's going to have semantic implications on the state of the system, then obviously you can't ignore it. Give you an example, like creating a VM. If you're creating a VM is actually modifying state. So if you don't understand what create VM is, obviously you can't do it. If you come across a VM and you don't understand in state and you don't understand what it is, obviously you need to stop right there, because who knows what you're going to do that could corrupt that VM, that resource type that you don't understand. So in that case, fail with a version error, but try to be as liberal as you can with forward compatibility to make those kinds of update ordering problems go away. This one, customers started to complain that when they were creating VMs, they would fail to create. Now, what's going on with these VMs that are failing to create? Here's the incident information. So we dug into the logs, and we showed that the VMs that were failing to provision were using only one of two different images. Now, what are those images? Well, they'd just been uploaded. So that's a clue right there. Something we just did, these are new images, are causing these VMs to fail. And let's go and make sure that the customers are really seeing something that's a consistent failure, a consistent error. So we go try to deploy VMs using those same images, and we also get the same problem. So this isn't like some random race condition. This is like every time you try to create from these images, it fails. What's wrong with these images? We check them against the bases that we had, and they're corrupt. They're different somehow. So what happened here? Let's go through the flow of what happens when we update an image in Windows Azure. These are OS images, of course. Every month, we've got a new OS VHDs that we produce. After we do boot performance and prefetch optimization, we add that information to the VHD, and then we upload it to the platform image repository. That gallery that you see when you go to create new VM image is pulled from repositories in each region, depending on where you're provisioning from, to pull OS images from there. Before we make these things live, we have testers go and do sanity tests on these things. So they will provision a VM using the image, and then they'll RDP in and do some tests inside the VM to see if the image is actually healthy. Again, this is a case where ultimately all of this should be automated, but automation takes development work too, and so while you're getting to that, sometimes you got to fill in with manual labor, which you have to do in this. The problem, as we identified it, is that somehow during that image upload, the image had got corrupt. Now, how did the image get corrupt? Well, we weren't using any kind of verification, integrity verification on the upload to ensure that there was not a network transmission problem that corrupted the image. And why didn't that tester detect this? Well, they'd made a human mistake. Again, drilling home that automate. Humans make mistakes. Many of our incidents are caused by humans making mistakes, places where we haven't filled in with automation. In this case, the tester was actually testing an image in stage instead of production. So they were like, oh, I'm testing the image, looks like it works. It's actually the production image that was corrupt, but they weren't testing it. So that's why that was a miss there. So the bottom line is, in the cloud, assume data can get corrupted in flight, assume data will get corrupted on disk, assume data will get corrupted as you handle the data, and do integrity checking. And this is a lesson that we've learned the hard way here as well as in other places. In fact, we found that running at scale with Windows Azure Storage, a lot of people say, I'll just use CRC or CRC16, CRC32. We found actually that at the rate of data transmission that we've got of data in our data centers, that we've got to use CRC64 because there's that much volume that CRC32 is going to let errors slip through, network errors slip through. So we've decided, we've just institutionalized this. If we're going to do integrity checking, it's CRC64 because that's the way we can ensure that we're really safe at scale. Now let's talk about some major fail cases. This is a VIP swap case that happened not too long ago. It was the end of last year. VIP swapping. What is VIP swapping? Oh, well, actually, this one is a public one. And the way that it was discovered is that users started to complain that they would do a VIP swap operation, and then they would go to the portal, and they wouldn't be able to do anything to their deployments, that they just VIP swapped. So this, because it was customer visible, and because some customers like to tell the press about their problems with cloud providers, this showed up. It's one of the most awesome headlines I think I've ever seen. This is really exaggerating the scope of this problem. Only a very small number of customers ran across this. Not everybody doing VIP swaps hit this problem. Only some people doing VIP swaps ran this problem. Not everybody does VIP swaps. You've got to be doing cloud service deployments, and you've got to be using VIP swaps to do upgrades instead of rolling updates. So this is a very small, kind of isolated. Now, of course, we take it very seriously, but this is a little bit of an exaggeration as far as the impact on the world. So what the hell is a VIP swap anyway? You know, VIP swapping was really popular back in the 1970s, and it's come back into vogue. Now, what VIP swapping is, and how many people have done a VIP swap deployment in Azure? Swap deployment is called, is the official name. So how many people have no idea what I'm talking about? Let's see that. All right, so let me explain this. And you can have two versions of a cloud service in Windows Azure. Cloud service being a collection of virtual machines, web and worker roles, PaaS virtual machines. So you deploy one instance, that's your production instance. It's got an IP address that's a stable IP address. It's got a DNS name that you can bring and map to it, a CNAME that you can map to that thing. So that is your production site. Now, there's two ways to update that code. One is to do a rolling update. So it's an in-place update where you go updating slice by slice of that code to minimize downtime, and you update the bits in place. The other way to update is actually deploy a brand new version of that code as another cloud service with its own VM side by side with the first one. And we've got this built into our PaaS APIs as deployment slots. And so there's a production deployment slot and a staging deployment slot. And when you deploy a cloud service into the staging deployment slot, it gets basically an ephemeral IP address, and it gets a GUID as the DNS name. And then you can do some tests on that, against that. It's not publicly accessible. Nobody knows about it. And then you hammer on it. Once that looks good, you're ready to say, OK, this is going to be now the new production code. So you perform almost an atomic transaction to promote the stage version to the production version. Now, when that promotion happens, the production code becomes the stage slot code. And now it's accessible using that GUID IP address and that temporary GUID DNS name and that temporary IP address. The production IP address and DNS name now is pointing at what was previously the staging one. So it looks a little bit like this. Two side-by-side services. And then you do a VIP swap, and all that is crossing pointers. It's actually not moving the code at all. All you think about it is just taking those DNS IP address mappings and then pointing them at the different cloud service input network endpoints. So it's a very, very lightweight operation and very popular with, lots of customers actually use this to do updates. What happens underneath the hood for this thing is that RDFE uses storage tables to cache, to store the state of each of those cloud service deployments. And for each cloud service, it's got 2 rows in the table, Azure storage table, 1 row for production and 1 row for stage. And it stores information like what is the status of the roles. The roles are like the web role front end, the worker role middle tier, and it'll say whether it's healthy or not healthy or in the middle of updating. And then it also stores whether it's the production slot or the staging slot and the IP address and the DNS name and other things like that. So when these rows in this table get updated obviously for a couple different reasons. One is the state of that cloud service changes, like the role moves to healthy to unhealthy, or somebody starts an in-place update on the thing, and so now it moves to updating instead of healthy. The other place where it gets updated is on the VIP swap itself. And so if you watch the animation, bam, VIP swap. The only things we've changed are the stage, production slot, and IP addresses there. I changed the color from the colors to represent the different roles. So green is production, orange is stage. And this is done transactionally when we do the VIP swap using opportunistic concurrency with tables, where you can say update these combinations of rows, these entities. And if there's a collision on any of them, then don't update any. Only allow it through if all of them get through before anybody else updates it. So it's transactional in nature. Now the problem that we ran into on this particular situation is that a bug in RDFE introduced by a developer in an update that went out that day introduced a race condition where a change could be overwritten by update to that state over there, those role states. And so what that meant is that you would do a VIP swap, and along comes cache an update to the state, which is really just storing the cache state of that update, of that service, but it's updating the wrong row, and it does it as a full row update because it's not a single cell update. And bam, you've just overwritten the whole row, and now there's 2 slots that say that they're staging. When that happens, RDFE says, well, I don't know what the hell is going on here, so I'm hands off on this thing. And that's why users were unable to do any more modifications on their cloud services that ended up in this state. So the issue here, why didn't we catch it? Why did customers catch it? This was a slow-moving bug. You know, when you operate at cloud scale, there's always failures of different types. And a lot of those failures are recoverable failures. So the retries recover from them. So the issue here is identifying unusual error rates from kind of the background noise of error rates. And the reason we didn't detect this is that the rate of failure was so just marginally higher than the standard rate of failures for these kinds of operations before that it didn't throw off any alerts. So we've instituted, by the way, the developer, we asked him, what the hell did you do? He said, well, ADO.NET's really kind of unintuitive, and so that's why that race condition is there. So the rule we instituted is nobody's allowed to use ADO.NET anymore. No, that's not the reason. That's not the way that we dealt with that. That's not the rule. What we did is a rule that we kind of knew. This is kind of one of those ones where you know it, but there's actually a nice enhancement to the rule that we had before, which is always update in stages. Now, we did update to test, pilot clusters and the test RDFE and hammered against that. Again, didn't see this kind of error rate higher than the normal situation. So what we do now is we have multiple versions of RDFE in production. When we're going to deploy a new one, RDFE vNext there, we just direct a slice of traffic to that. We start out with 5%. And that's not enough, though. Would that have caused just that redirection? Would that have thrown the alert? No, it wouldn't have, because that thing is just marginally having more errors than the other two. The only way you're going to detect that is by comparing the failure rates of that thing versus what you already had. And if you see a difference, even if it's small, that is something you should go investigate before you lean on this thing more heavily. Now, of course, as you get more confidence, redirect more traffic, redirect more traffic. Rule: never let the amount of traffic you redirect to the new one exceed 100%. That's really bad. And then once you're ready and confident, then you upgrade everything to V2, and you've basically marched on to the new thing with a lot more confidence. So this is the new pattern that we have in RDFE. Here's one that also, it didn't pick up any public press, but it was very painful for some of our customers. And this one is an accidental deletion, as you can probably guess. So Azure is a complex system that's grown up over the last 7 or 8 years. And in the original days of Azure, the way that we would onboard some of our key strategic partners is to go reach and directly interact with them and help them onboard Azure by provisioning their subscriptions on their behalf for them. So we would go and provision them and give them special capabilities that would be ones that were capabilities that we hadn't released to the general public yet. And those subscriptions are kind of in the same pool as the subscriptions that we create internally for ourselves, the Microsoft kind of internal subscriptions. And now when we create these Microsoft internal subscriptions, we're creating them all the time because we're always doing testing of new capabilities with special subscriptions. And so what happens is that we end up with a lot of subscriptions that end up becoming stale. Nobody's using them anymore, and we need to go clean them up. So we age them out. So periodically, we go do this. And the person that was doing this for a whole set, we had this batch of internal subscriptions that we needed to be cleaning out. And the person that went to go do this didn't realize that we just instituted a new process for the subscription deletion, which is to go through Windows Azure Frontline. It's our frontline services that are kind of the interface to customers and controlling customer subscription provisioning and capabilities. That the new flow was to submit to them and have them make sure, hey, is this really a subscription that should be deleted? There's not some error here that somebody requested deletion and it shouldn't. So it's kind of a two-phase delete to try to stop errors from getting into the system. This person wasn't aware of this and kept on submitting subscription deletion requests into the system. And the number of subscription deletion requests started to grow so high that it became too onerous for Frontline. Frontline's like, wow, that's a lot of subscriptions to go wading through. Why don't you, those are marked all MS internal, so why don't you guys just go do a batch delete on those? So they go do a batch delete, bypassing the process. Now what happened, like I said, is several subscriptions had been created on behalf of external customers. The ironic thing is that these customers are some of our most strategic, important customers, and we just wiped off their subscriptions. And so the frontline checks would have stopped this. Again, bypassing the normal procedure, inadvertently allowed this through. Customers graciously let us know, politely, that we had deleted their subscriptions. So what did we take away from this? Well, when these subscriptions consist of these resources like storage accounts and Azure databases and VMs, and what happens when you delete the subscription is we go and just delete, 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 delete. Fortunately, we were able to recover all of their data, all of their storage accounts, all of their databases, we recovered successfully. Why? Because from the very first day we launched Azure, we had this data retention policy. Having run into this early during the preview of Azure, during our own uses of Azure, when we made mistakes and deleted stuff, we were like, oh, crap. Wish we could get that back. So we said, well, we better do this as a safety net in general so that we don't run into this with customers. So this is the text from there. This is right on that page right there. So when a subscription expires or terminates, we will retain any customer data you have not deleted for at least 90 days so that you may extract it, except for free trials where we may, and then we don't finish that sentence, so we can do whatever we want. No, that's really not true. Yeah. But what this does is actually you can, after you delete your storage account or a database, you can come back to us within 90 days and say, it's really screwed up, I need that back. Now, we'll give it back to you. Of course, we will charge you for that 90-day, for that time period from the deletion to when you recover it, which normally is invisible to you because it's just us doing that as a service to you. So we charge you to basically reactivate and back pay the charges for keeping that data around. The miss in this case, though, was that the subscription itself was deleted, and we didn't have a data retention on subscriptions. So what this meant is that we had to go recreate those subscriptions from scratch, really dealing with scraping data from here and there and talking to the customer, and you had VMs in the storage accounts, and which ones, can you help us with the names? And then let's cobble those back together and put them back into a fresh account subscription for you. And try to make that subscription have all the capabilities it used to have. Really painful, painful thing for us. So we instituted more rigorous standard of whenever it comes to deleting these things, deleting anything, to use soft delete where possible. Now, this isn't always possible. There's cases where you, like think about a storage table. Can the storage table keep around every table entity that's deleted? No, that's just not something that scales. I mean, that's a ridiculous amount of storage. But for these kind of very important kind of I'm deleting a big thing, make sure you do soft delete. Golden rule that we now follow throughout the system. And when we do a soft delete, just like when you delete your storage subscription, you no longer see it in the portal, it's no longer visible to you, you can't interact with it. So we make this thing invisible, inaccessible to the customer. It's got a special state called deprovisioned. And that lets the whole system know, hey, this thing is there, but it's off limits. And then we start the timer on it. And actually, it's a little more complex, the flows than this, because there's several checks along the way based on, on different dates and what's happened to the thing, especially when it comes to our payment systems, because customers can enter these states where you haven't paid your bill. All right, now we need to start a timer on that. Now you really haven't paid your bill. Now we move into deprovision. Now you really haven't paid your bill. Now we try to notify you. Things like this where we just escalate this lockdown on your thing until we end up falling into this, which is the soft delete followed by the, okay, you're gone, see you later. So that is a golden rule learned the hard way. I've got one last case to share with you. This one also is very public. How many people, how many people were affected by this one? Woo, yeah, quite a few of you. Not one of our proudest moments. Almost a little over a year ago, February. Februarys are not good months in general for Azure. Except for this month, this February, actually we did pretty good, didn't we? I think we did pretty good. We had the Leap Day thing, by the way, if you don't know what I'm referring to. Leap Day 2012, that's when we had our biggest, most flagrant outage ever. That one was because, and I would have included that one if I'd had time. You can go read all the gory details in the public post, which I helped co-author, which describes the whole thing. I've also got Windows Azure Internals presentations I've done at previous builds and tech eds where I walk through that whole thing. But the key learning from that one is that time is a single point of failure. And so we try to get rid of single point of failures in the cloud. We haven't been able to solve that one yet. Now, and we know we've got another Leap Day coming. The last one was 2012. So we've got 3 years to prepare for the next one, which is just awesome. So it gives us plenty of time. All right, so this one, the certificate cert outage. This one, SSL connections to Azure Storage started failing at exactly 12:29 p.m. on February 22nd of last year. And customers started to notice it immediately. And so here's a question somebody posted right around that time in the Windows Azure forums. So is it just me, or did the HTTP certificate for Azure Storage just expire? So one of the Azure forum moderators helpfully answered, yes, it must be you. No, I'm just kidding. Just kidding, they didn't do that. Well, we noticed this too very quickly, and this is our dashboard at that point in time. It looked a lot greener this morning in the keynote, didn't it? So this is the thing. We did update the certificate. It's not like we forgot to update the certificate. We updated it. In fact, we updated it with plenty of time. Let me talk a little bit about the way that we manage certificates, or did, in Windows Azure. So when we've got this place that we stick our certificates. It's a secret place. We call it the secret store. There's only one rule for the secret store. There is no secret store. And this secret store, this is where once a week we have a check, sweeps all the certificates in that store. And if any of them are within 90 days or 180 days of expiration, they fire off an alert. And that alert triggers, hey, we've got a cert. It's on the radar, coming towards expiration. 180 days, 6 months. And that gives us enough time to figure out how we're going to get that cert pushed down into production. An update of that. Well, first get the cert renewal and then push it out of production. So the team at that point, at some point after that alert comes out, goes and gets a new cert. Fresh cert, pushes it into the secret store. So that process we actually followed. That cert had been updated in December. Actually, there were 3 certs involved. Tables, blobs, and queues. And all 3 of those certs were updated in December and in the secret store. So what happened once they were in the secret store? That weekly check said, cool, everything's updated. Now, what's supposed to happen after the cert gets updated in the secret store is that, no, it's actually January 7th they updated it. What happens is that they, at that point, say, schedule a release that those certs are going to go out into production with. And they did that. And of course, they have to schedule a release before the expiration of the cert. So they scheduled a release way ahead, several weeks ahead of that cert expiration deadline. Now, what they failed to do was, after they had the meeting where it's like, here's our deployment schedule, let's push the certs out on this day, on this storage update, whatever, is that nobody wrote it down, that update was the cert carrying update and it had a deadline on it. And so a week later, there's some bug that shows up in storage, some performance issue, and they say, oh crap, we need to roll out a hotfix. And this hotfix is going to take a while, so that's going to push this feature update out a little bit. Out a little bit over February 22nd, unfortunately. And nobody realized that they were violating the deadline when they pushed it out. So what happens is, of course, that the update was there ready to go. The cert expired, but the cert wasn't in production. So the real breakdown of this wasn't the fact that we'd not set a deadline on the deployment, although that's a very good thing to do. If you've got some deadline-driven thing that's like, crap, the system's going to fall over unless we get it out by this date, of course, you need to carry that through your system. But the real problem was we didn't monitor production, the certs that we had in production. We only monitored the secret store, assuming that whatever is in the secret store reflects what's in production. That was the flaw. In fact, this one is such a mind shift from the way you look at box product development to the way you deal with services, which is really, when you deal with services, it's about the whole life cycle. From the first lines of code to pushing it into production, to updating it in production, to maybe even sunsetting it, fixing bugs, adding features, debugging things, debugging failures. That whole thing you're responsible for. It's such a key aspect of looking at the development in this new DevOps world that the storage team, now as the head of the storage team, Brad Calder, he says that one of his questions on the interview loop is he tells them this story of the cert expiration and then says, before he gets to the slide, he says, what is the real problem here? What did we screw up with? To drive home the fact that it is you've got to think end to end when you're dealing with cloud services. And that's where the breakdown was. So now we've instituted a new policy At 90 days until expiration, when the alert fires, it shows up on a report that's reviewed by the vice president of Azure. So we've got several vice presidents of Azure. They all see this report. It says, these are the certs that are within 90 days of expiration. Now, when that cert gets to 14 days within expiration, the VP shows up on your report at that point. It's that bad. So the rule is thinking through the whole life cycle. Now, one of the things that we're also working on to mitigate this is not the right way to deploy certs in this kind of configuration. What we've realized is that there's certain kinds of configuration that is not real configuration. It's not configuration in the sense that this is a change to the way that the service operates. It is kind of a registry of state that just needs to be absorbed by the service. And for this kind of configuration, instead of pushing it with code updates, this should be a pull by the service. So we're developing, so one of the things that we're doing is going to make it so that the services themselves are periodically pulling from the secret store and alerting themselves from production if they've got a cert that's about to expire and they're not finding a fresh one in the secret store. So that's one thing we're doing. The other thing we're doing is that we've literally, because we do cert-to-cert authentication between our services inside of Azure, and we've got, obviously within each region, we've got hundreds and hundreds of different services, ones that are publicly visible to you, ones that are internal. And then we've got multiple regions around the world. We've got literally tens of thousands of certificates that are PKI certs that are not ever visible to the public. There's no reason to have a publicly visible PKI cert when your services are just talking to each other and trying to authenticate themselves against each other. Like, are you really the front end? And I don't need to trust, semantic VeriSign to know. I need to just trust Microsoft. In fact, what we're doing is developing a managed service identity system where the services themselves create their own certs, register them with a central cert authority, which it's really Windows Azure Active Directory version of it. And at that point, and there's a scale-out architecture. So for scale-out services, one of the front ends, for example, says, I'm registering this, I'm creating the cert, registers it, and now the other front ends can realize that there's already a cert for the front end's identity, can pull it off from the front end, from the certificate store, and then authenticate to other services using that cert. And the other services can go to the directory and say, all right, do I trust whoever's talking to me? And the directory will say, yeah, that's a cert that I've actually validated. I trust the front ends that went and registered that. Those are really the front ends. So with this system in place, which we should have in place in the next 6 to 9 months across the internals of Azure, we will be getting rid of our PKI certs so that this problem becomes one that's only for publicly visible PKI certs. We can't get rid of those because the system's built on public trust for publicly visible PKI certs. But we're moving to that other system where it's a pull rather than a push to get this kind of stuff out of their production. So lots of lessons learned from this case. So that brings me to the end of the session. And this is a list of all of the different areas that we covered here. You can see quite a few of the minor hashtag fails and 3 major hashtag fails, lots of different rules that I hope you picked up on the way, made you think about, maybe I didn't think about that explicitly as I go developing my cloud service, and now you can avoid the same kind of mistake. And it's interesting because some of these rules, like the code hygiene one, applies to box product rule too. Even the logging one does too. But what cloud scale and cloud services bring to the table is a bunch of rules that are new because of the DevOps and full life cycle, as well as really emphasizing some of those rules that were box product rules that you could get away with not really paying attention to, but bite you when you're operating with a hands-off environment at scale where you're actually operating the thing and responsible for keeping that thing running. Also, this is the first time I delivered this talk, and this is kind of an experiment. Like I said, Cases Then Explained for cloud services, sharing you what we learn in Azure. If you like this talk, please let me know, fill out an evaluation. Also, just like the Cases Then Explains, where I get lots of learnings from people like yourselves that are troubleshooting successfully and come up with a solution you want to share, If you come up with a rule yourself based on some incident you have with your own application or service, please share it with me. That's always great to have us all learn from each other as we go into this world together. So with that, I want to thank you very much for coming to the session. I hope you found it useful and interesting. Hope you have a great build, and hope to see you at the next build. Thanks very much.